We are going to be have an opportunity to chat with our astronomer, Rachel. How's it going, Rachel?
Well, thanks. How about yourself?
Oh, it's going along, and actually, it the clouds just parted, so we have a little bit of nice weather over here in Kitsilano. But this week is Rachel. Did you know that it is World Ocean Week this week?
No, I didn't actually.
Of course, our planet is mostly water, and this week is World Ocean Week. So we decided to devote our theme this week to tides, which is something that we talk about in our school programs, but it also is related to how we understand our planet and how we understand sort of the relationship of other worlds that may have tides as well. So for the next 30 minutes, we're going to be delving into the theme of tides. Rachel, you are going to be telling us a little bit about how they work from a celestial point of view. But of course, water and oceans, that's not really our main thing that we do at the Space Center. So we decided to reach out to one of our colleagues at the Vancouver Aquarium, who's going to tell us a little bit more about oceans and some of the creatures that are affected by tides. And that is Catherine Poe from the Vancouver Aquarium. Hi, Catherine.
Hello everyone. I'm happy to be here and talking about animals under tides.
No, this is really great. This is a nice to have these different divergent perspectives. So it should be really fun. So everyone out there on YouTube, if you have questions for Rachel or Catherine, just pop them into the comments. We are going to devote the next half hour to answering those. So let's get started with you, Rachel, and let's look at tides from a celestial point of view.
Sure. So I'm hoping just to give a brief introduction to tides and then passing off to Catherine to talk about the cute little creatures that we can find in tidal pools. So when we talk about tides in daily life, chances are you immediately think of ocean tides as sea levels rise and fall. But when astronomers talk about tides, we are talking about a force that has had a hand in shaping all the objects in the universe. It's responsible for many diverse phenomena, including tides, tidal locking, tidal heating, the breaking apart of celestial bodies, and formation of ring systems, and even, in extreme cases, the spaghettification of objects. But to understand tides and tidal forces, we must first understand the gravitational force. Now, gravity can be thought of as a force. It weakens with distance and is measured from the center of mass of an object. Now, for a sphere, that happens to be right in the center. Now, let us imagine for a moment that you are a giant, towering at almost 160 kilometers tall. Now, the gravitational force felt by your head would be actually 5% less than the gravitational force felt at your feet. Now, this change in the force of gravity over distance is what astronomers call the tidal force. Now, tidal forces are important for understanding how tides work. Now, let's consider just the Earth-Moon system. The Earth and Moon exert a gravitational influence on one another, and the tidal force they exert depends on the strength of the gravitational force, how far away the affected object is, and how wide the affected object is. The wider it is, the more the force of gravity changes across it. So what is the effect of the tidal force? Well, really, it just stretches the object. Think about it. You're applying a greater force at one end than the other. So you're pulling harder on one end of the object, or in other words, you're stretching the object. Now, even though the moon is smaller than the Earth, it can still stretch the Earth and its oceans with tidal forces. Now, the side of the Earth that faces the moon is tugged on harder by the moon than the other side. So the Earth stretches into a football-like shape. Now, it might seem odd that there are two bulges, but remember that we measure gravity or differences in gravity from the center of mass. So the side of the Earth facing the moon feels a stronger gravitational tug than the Earth's center. So it's pulled or bulges towards the moon. However, on the far side facing away, it feels a weaker force toward the moon than the Earth's center. So the center is being pulled away from the far side, just like this. Or equivalently, the far side is being pulled away from the center. Thus, the tidal force is the strongest on the sides of the Earth facing towards or away from the moon, and weakest halfway between them on each side. Okay, so what happens when we throw the sun into the equation? So let's look at a special case during a full or new moon. Now, during this phase, the sun, the Earth, and the moon are all in a line, or what astronomers call a syzygy. And that happens when 3 or more celestial bodies are lined up in a straight line configuration, just like this. Now, when this happens, the sun's gravitational force adds to the effect of the moon, giving us high tides. And in fact, it actually gives us the highest high tides, or what we call spring tides at full and new moon. So now the next question is, well, when do we get the lowest low tides? Well, in this case, the forces of the sun and moon are in what we call quadrature, or in other words, the moon is at 90 degrees to the sun, and it's in its first or third quarter phase. Now with this alignment, we have two forces pulling in different directions, so the two effects kind of cancel, and we get the lowest low tides, what we call the neap tides. So here's a summary. We have spring tides and we have neap tides. So we have the spring tides with the greatest difference between low and high tides. We have higher high tides, lower low tides, whereas with neap tides, we have lower high tides and higher low tides. And remember, with neap tides, our sun and our moon are perpendicular to one another, whereas with spring tides, we have that really crazy word with a bunch of Y's and Z's. It's called syzygy, when we have that perfect alignment between our sun, moon, and earth. And that brings me to the end. So I'm going to throw it back to you, Michael.
Awesome. Yeah, I think you just gave everyone some tips on how to win their Scrabble game today. Syzygy is the perfect word for that.
It's a great trivia question.
So Catherine, when you're thinking about tides in that way, when you're thinking about the animals, are there some animals that are more connected to the moon in that way? That are when you're thinking about tides, what are you thinking about?
I'm thinking about it very much from the perspective, a lot of the time, of whether or not when is the good time to go out on the beach to discover them. I can get right down to when I'm trying to find the animals, I need to understand how the tides are going so that I don't go at the wrong time and be there on high tide and not be able to see any animals. So usually when I think about it from that perspective. But as a person who teaches people about animals on the seashore, I would also think about it from a perspective of planning. So if I were to plan a program for people to come out and explore animals on the seashore, when's a good time to do that? So usually there are what's called tidal charts, because of course the astronomers have explained all this to us. We're able to actually look at when the tides are happening, when is the highest tide, when is the lowest tide, and how low is low, how high is high, so that then for those of us who program this kind of stuff, we can actually look, our lowest tide is going to be on this date, and it's going to be at 0.05 feet or 0.01 meter, and therefore we can actually plan our beach walk around that time. And so as people at home, when you want to take your kids out to go for a walk and be able to explore low tide, that's the type of thing you would want to actually think about as well.
Interesting. So of course, everyone out there on YouTube, if you have any questions for Rachel on the celestial effects of tides, tides can be complicated. Rachel did a really great explanation. So don't be afraid if you have any questions or want more of a clarification. Throw it in the chat and we'll get to it. But for now, let's go over to you, Catherine. And you have, you've got some slides that you can share with us, and I can throw those up as you talk about the animals that are affected by tides.
Yes, absolutely. Anytime, Michael, you could bring up the first slide.
Sure. Okay. So let's start off. We're going to talk about tide pools, I think.
Yeah. So the idea is what happens when the tide goes south. So when the water leaves the shore, what do they uncover? And it's something like this. So this is actually a photograph that was taken of Stanley Park along the shores, because of course that's where the aquarium is. And you'll see that many of the sea stars that would get left stranded on the shore tend to seek the water, right? So they're on the water side of all this, but some of them get stranded pretty high up. Normally what would happen is these animals would actually be on the shaded side of the rock, but because we were trying to take pictures, we moved the sea stars over to where the sun is so that we can take pictures of them. And I will tell you what you need to do if you do move animals at the end of all of this. But for now, let's just talk about the animals that you tend to find and where you might try and find them. So imagine you're an animal, lives under the water. You actually like cool water. You depend on water to be cool, and you also breathe salt water. And then all of a sudden, it just left your home, and now you're stranded high and dry. So these animals, many of them have adaptation that allow them to live in this kind of condition. And then many of them have behavioral things that they will do. So a lot of the animals, as I said, will probably go behind where the shaded area is on that rock. Many of them will be under the seaweed. And a lot of them will be looking for tide pools, be in the water. So if you're a person looking for animals, that's sort of the places you probably want to try and look for them for. You can move to the next slide, Michael.
Sure. So we're going to go to look at some feather dusters at low tide.
Yes. So you'll see on the green algae actually on those rocks that we just moved. And again, on this slide here up at the top left, you can see some green algae that just dry out. So some of the species that live on the shore, they just do that. That's their adaptation. They can dry out and then rehydrate when the water comes back in. But then some animals, the ones that live in this tube, will actually retreat. So believe it or not, this is actually a worm. These are marine worms. They live in a colony. And then when the tide goes out, they pull into their tube. And of course, that's where some water is left, so they can keep themselves moist. They can keep themselves cool, away from the sun. They can keep themselves, away from the drying heat of the sun, and also from wind. It can be a bit windy on the shore, and also protection from other animals that will come and eat them when the tide goes out. So this is a chance for animals like different types of birds, gulls, crows, raccoons, mink, even snakes will come down to the seashore and actually look for animals. So these poor marine animals have to contend with not only losing the water that they need to breathe and, have to figure out how they can stay cool or adapt to warming water, but they also have to worry about predators that will come and eat them when the water goes out. And of course, they have it the other way. When the water comes back in, they also have to worry about the other marine animals who will come and eat them when during high tide, right? So they get it from both sides. But anyway, let's have a look at what these animals actually look like when it's high tide.
All right, let's move on to high tide here. Wow.
Yeah, aren't they beautiful? So this is their actual proper name is feather duster worm. That's one name. Sometimes they're also called parchment tube worm. And it's because of the parchment-like, it's made out of protein, and they actually create that tube. So as they grow bigger, they lay more tube out, and they just get longer and longer as they age. But so this feather duster part is actually their feeding part. And it's very delicate, as you can see. And what they do is they will stick that out when the water comes in, and they're trying to catch tiny animals for food. But they obviously need to protect that when the tide goes out and try and keep it moist, and that's why they would pull in. So you can see in some of these, they're halfway out of their tube, and some you could see at the top left there that have pulled into the tube. So again, if there's a predator coming that will try and come and eat them, there's a fish that wants to nibble on that feather, they'll just bring their tube right in to get some protection. Next slide.
It's funny, like, just look from my perspective, looking at these photos, they seem so alien to me, but
They are. Well, There's the exploration of space aliens, and then there's the exploration of underwater aliens. Right?
So, the one thing I noticed in that picture that you showed previously, Catherine, is that I thought I saw some mussels in that previous picture, but here are some
Yes,
mussels too.
yes, there are mussels in that picture, and those mussels are actually different from these mussels.
Okay.
So those mussels that were hanging out with the tube worms are what people would call blue mussels. They're, scientists have since divided. They used to be in one big group, and there was just these blue mussels that are found around the world. And since then, taxonomists have actually looked at their genetics and have split them up into different, they're called bay mussels now, and different ones. And the ones that are found along our Pacific coast are a little bit different from the ones that are found on the East Coast, but they are a type of blue mussel. And their shells are a little thinner. These ones, the ones that you're seeing now in this slide, are actually West Coast mussels. So they're called the California mussels. You could see their shells are super, super thick. And one of the things that these colonial animals do, so the parchment tube worm is doing that, and then these mussels are doing that, is they clump together. And again, that's some kind of protection when the water goes up, because when they clump like this, they actually are able to shade each other. So they can keep each other cool when the sun is shining on them. They also trap bits of water, so little bits of water kind of in between them to, again, keep them moist, keep them cool. So clumping is a very common thing that animals will do along the seashore. When you start to explore, you'll start to notice this kind of stuff. But when animals clump like this, just like with the parchment tube worm, basically are hosting some mussels on their parchment tube, these mussels also have other animals kind of growing on them, and in between them, they become a mini ecosystem almost of little animals growing kind of in between these animals. So when you're exploring, don't just kind of look there, look deeper, look inside, look in between, because you'll start to see there will be worms in there. You can see on this photo, there's actually barnacles growing on these mussels, but also there are these very flat snail-like animals called limpets. And if you start to dig a little bit more, you'll probably find little shrimp-like animals that are called sea lice. Technically, scientifically, they're called amphipods. But yeah, they're these tiny shrimp-like animals that would live in between these things. So they're so full of life on the beach. It's like everywhere you look, there's actually life there, even though it looks like rock sometimes. Barnacles especially.
Absolutely.
Yeah.
So let's move on to.
Let's go to
Yeah. So let's talk about what you would expect would be good behavior for people that are going to go out and do some exploration.
Yes. Let's do that. So here's, again, Stanley Park, Lumberman's Arch, where we do quite a bit of our programming at the aquarium. And we have a group of people that we've taken out on a beach walk in one of our camps and clubs. And you can see, so the tide has gone out. It's exposed a lot of the rocks. And as we talked about a little earlier, most of the animals will be where? I'll leave you a few minutes to think about that. They will be under the rocks, you're right. So what you would need to do if you were to find animals is you would have to gently lift the rocks up to actually find all kinds of different, sometimes you'll find fish, but lots of times you'll find crabs, worms, and animals even living just underneath the rock itself. They would be attached to the rock themselves. Also, as you explore further on the beaches, you would probably see little pools of water. That's a good place to look because, of course, the animals will probably go there so that they can breathe. And even though sandy shores look barren, they're actually not. A lot of the animals are living just underneath the sand. So a little bit of digging might expose clams, again, shrimp. Sometimes there's certain types of shrimp that live under the sand. When you see holes on the sand, when you go out on a beach walk, there's usually animals that live in them, and they're all different types of animals. They can be worms, shrimp, lots of different types of species of clams that live underneath. So you would want to do those kinds of stuff. But when you go out, you need to be really mindful of where you're walking, because there's life everywhere. You don't want to be crushing animals. So just like be really careful, look at where you're walking. You also could hurt yourself. Barnacles are painful. If you ever fell on a barnacle, which I have done exploring on the shore, you will get cut. So, you know, you want to like step gently, walk carefully. If you lift the rocks, if you dig something out, you want to make sure you're putting everything back. If this were a really low tide, on a really good spring low tide that Rachel talked about, you know, this water would be out a little bit further. A lot more of the seaweed would be exposed. So if you were going out and you see seaweed, by the way, are slippery. So if you step on them, you could actually slip. So you need to be very careful about that. But again, where would the life be if you were looking for animals in that condition? They'd be under the seaweed, right? So if you do lift the seaweed up to look for the animals, just make sure you put it back so that they can go back and find their shelter again after you've disturbed them. You can see the people in this photo actually have brought buckets out. What you can do if you wanted to is actually put some seawater in the bucket, put some of the animals in there if you wanted to watch them a little bit more and how they behave in water itself. If they were actually completely stranded, you know, then you would see barnacles actually come out. You'll see their tiny little feet come out, look for food. So just be gentle, be mindful, put everything back as you found them so that the animals can go back and actually find their home again. These are, just remember, you're visiting animals in their own home and you don't want to be rude and you don't want to hurt them, right? And then the only other thing I want to leave people with is if you were doing a beach walk on the West Coast where the waves can come thundering in and you never quite know, you never turn your back to the water. You always explore moving with the water forwards and always be mindful of what the water's doing, because you could get, you know, if a big wave comes in, they could kind of wash you out. So you don't want that to happen.
Yeah. Awesome. Well, thank you so much, Catherine. That was amazing. And I like to think of this like what the exploration that you're encouraging people to do is almost like we are exploring like an astronomer would do if they were exploring a new world. You know, if we go to Mars, you know, and exploring, picking up rocks and looking underneath. Of course, I don't think there's any life on Mars like there is in our ocean. So maybe we should be going down to these seashores more and exploring them. This is you've really inspired me, Catherine.
Yeah, it is a very different, I mean, because we're such air breathing visual animals, you know, the way we look at things and the way we think about how we live is very different from how animals that live in water live, right? So it is exploring kind of an alien world. But in our own world.
Of course, yeah. I've got about 7 minutes left. If anyone out there has any questions about how tides work from the moon and the sun perspective, or how the tides affect waters, the animals in these tide pools, please put them into the chat as we go through. Rachel, there was one aspect of tides that you didn't touch on. You sort of alluded to it, you know, when the sun comes into the picture. And of course, we do have these things, you know, called king tides. And maybe Catherine, you could maybe tell us a little bit more about how the animals are affected by king tides as well. So tell us a little bit more, Rachel, about how king tides work.
Right, so that's when our sun and our moon are working together. And they're lined up in that perfect straight line configuration. And so when you have the gravitational forces of the sun and moon working in tandem, then you get your highest high tides. And, you know, we call them spring tides, but they're not really related to the season spring. But I like to think that it's the forces or the gravitational forces of the sun and the moon springing into action together. And maybe that's why they called it spring tides.
And Catherine, are these particular, these larger tides, like, is there any interesting aspects that affect the animals there?
So tides, can trigger certain behavior in some animals. So for example, usually a good full moon, for example, when the tide is happening, can trigger in the tropics corals to actually start to breed in tandem. So they will spew out their sperm and egg cases into the water. So you know, the movement of the moon and how the water is moving in the ocean has impact obviously on these marine animals, and it does trigger certain events, big events, usually in a lot of cases. And on a king tide, it just means that the animals have more space. Obviously, they kind of move up as the water goes up. They move up, and so there's more space for them to explore for a short amount of time until the tide starts to recede again. More space for them to look for food, really, in the end.
Right. Got a question in for you, Rachel. So, of course, we do know that there are worlds in our solar system that have water, and probably the most prominent of those is Jupiter's moon, Europa. So, obviously, there must be some sort of tidal forces happening on that world. Could you maybe talk about what's happening on Europa?
Sure, yeah. So the two moons in our solar system that are prone to having tides are places like Europa and places like Enceladus. And with Europa, like Europa's structure is similar to Earth in that it has, or thought to have, an iron core, a rocky mantle, and this surface ocean of salty water. And because, you know, Jupiter is so large and it's very close to Europa, there are massive tides happening on Europa. And I wanted to bring in Enceladus as well into this conversation because Enceladus has this really cool tidal heating mechanism. And I mentioned that at the very beginning when we're introducing tides and tidal forces. But the cool thing about Enceladus is that, you know, it's too far from the sun for us to expect it to have liquid water anywhere on its surface. But because of this idea of tidal friction or tidal heating, that kind of gravitational interaction between Saturn and Enceladus actually causes there to be liquid water on this moon, even though we expect it there not to be because it's so far away from the heating of the sun. And it works very similar to the way you can generate heat by rubbing your hands together. It's just like that, but gravity is doing that kind of friction to Enceladus, and we have things like water on places that we don't expect to have water.
Awesome.
That's amazing.
There
could be life in those moons, right? They're moons, correct?
For sure, yeah. And I like to think that Enceladus is a great place to start because you know, that has geysers, so it shoots out water vapor from its poles, and we can see that. And we have science instruments that pass by and they sniff those plumes of gas, and they found hydrocarbons there. So that's kind of like the first essential building block that we need for life. So I think that Enceladus is a really great place to start looking.
There could be life there.
Yeah.
Maybe what we need, you know, when we do go to these worlds, you know, because as we explore, we need more, you know, diverse voices. But maybe we do need a marine biologist to go and study some of these worlds because they'd be more knowledgeable about how life would work in some of these worlds. We could, Catherine, we could send you off to Europa if you're up for it.
I would love that.
One last question comes in. This is a question for you, Catherine, because you talked about barnacles, and they are very hard. Why are they hard?
Well, so for lots of different reasons, barnacles are hard because that's how they protect themselves. Really, they have a very soft body. They're actually, you know, people might not know this, and it could come as a surprise, but they're related to shrimp and crab. And they actually have, so on a shrimp and crab, their shells, their exoskeleton is hard. And on the barnacle, it's a little bit softer, and it's on the inside of that shell. So that they will build this shell to basically protect that softer body that they have. And then the hard shell also protects them from the sun, allows them to clump. It protects them when the tide goes out. So it's really there very much for protection, but that also means that the barnacle, so when it's a tiny animal, and when it's a baby, basically, in its larval form, it's swimming around in the water. And then when it's ready to become an adult, it settles onto a rock. So it sniffs out, it actually kind of chemically smells out where other barnacles live, and it'll choose to actually settle in those places where other barnacles are, and it permanently sticks itself to the rock. So once you stick yourself down, that's it for the rest of your life. So I can tell you all kinds of stories of adaptations around barnacles, but we probably don't have enough time. Just, allows them to kind of live. What do you do when you're permanently stuck on the rock, right? So if you have to mate and have babies and that kind of stuff, like what can you do? You're stuck, you can't move, right? Anyway, another time.
Yeah, and we should go into a whole. We can do a whole section just on barnacles. But of course, that's interesting that you say that they're related to shrimp and crab. But we don't think of barnacles like that. Because I think people see them and they just see. I think when I was a kid, I thought they were just rocks. But they're living creatures in there. But of course, we don't think of them. Could you eat a barnacle? Is like?
Oh yes, you can. So so the barnacles that you see on a beach, like if you were to go out on Lumberman's Arch, they're really tiny, right? So those ones you probably wouldn't want to eat, although sea stars love them and lots of other animals love to eat them. But there are bigger barnacles that are called thatch barnacles. And our First Nations people will go out to the beach and actually eat them. So they'll take a whole rock, they'll bring them back, they can steam them, and then you can knock the shell off the rock and actually just eat the soft parts on the inside. And usually they're very clever, our First Nations folks. They will actually go and look for these barnacles usually during their breeding season, because then you can have some yummy extra fatty eggs in there.
Oh, wow. That is amazing. That's a great point to end on as we look forward to next week. Because next week is the solstice, and that's next week's theme. And you know what? We are actually going to be doing on-site programming next Saturday, which is going to be the solstice. And we are going to be having a First Nations storyteller who's going to be doing outdoor storytelling for us. That is Dallas Yellowfly. So we're going to be putting that information up on our website on Monday. So check out that. Catherine, how are things going at the aquarium? Is there programs going on there over the summer?
There are programs happening online as well. We have researchers that come on every Thursday through our Ocean-Wise programs. And then we also have our education programs that come on. So if you just visit our website, you'll be able to find out. There's at least, I believe, 3 different groups of people at the aquarium doing different types of online programming. So
awesome. Wonderful. So check that out. What's the website?
It's vanaqua.org and ocean.org.
Wonderful.
Are both of those.
And of course, come right back here next Thursday at 2 o'clock. Rachel's going to have another presentation all about solstices in our solar system. So for me, from my kitchen, see you next week.
Thank you.